In the last video, we took a look at a combination of two different vertical transformations. I want to take a look now at a combination of two different horizontal transformations. So let's suppose I have y is equal to sine of 2x plus pi over 2. So notice I'm multiplying by 2 and I'm adding pi over 2. And I'm doing both of those things before I plug into sine. So they're affecting the input, they're going to affect the graph horizontally. I have an interesting question for you, because I'm going to notice that that's the same as sine of 2 times the quantity x plus pi over 4. All I did here is I factored out a 2. I can see that if I redistributed, 2 times x would give me back the 2x. 2 times pi over 4 would be 2 pi over 4, which is pi over 2. Now when I write it this way, I'm multiplying by 2, so that means I'm probably shrinking things horizontally by a factor of 1/2. And I'm adding pi over 2, so that would suggest that we're moving to the left by pi over 2. But here, I'm still multiplying by 2, so that suggests the horizontal shrinking by a factor of 1/2, but I'm adding pi over 4. So that would suggest that we're moving to the left by just pi over 4. And only one of those can be right. So pause the video for a minute. I'm just going to stand here. When you come back, we'll talk about how to figure it out. Welcome back. Okay, I'm going to just observe that if what I said was right here, that we were shrinking by a factor of 1/2 and shifting to the left by pi over 2, my point that's usually here at the origin for the sine graph, well, half of 0 is still 0, and then to the left pi over 2, that would give me a point of negative pi over 2, 0, if I did things that way. Whereas if I shrunk by a factor of 2 and shifted to the left pi over 4, that would give me a point of negative pi over 4, 0. So let's just plug in and see which one works. Okay. If I take negative pi over 2 and I plug that in here, and it doesn't matter which one I plug it into, I should get the same thing. If I plug in negative pi over 2, when I multiply it by 2, that would make it negative pi plus pi over 2. That's negative 2 pi over 2 plus pi over 2. So that's negative pi over 2. Sine of negative pi over 2 is negative 1, not 0. So that point is not on the graph. We did not shift to the left by pi over 2. If I plugged into this version, I get exactly the same thing. Negative pi over 2 plus pi over 4 would be negative pi over 4. Times 2 is negative pi over 2. This is negative pi over 2, no matter how I get it, if I plug in negative pi over 2. And then sine of that is not 0, it's negative 1. But let's see what happens if I plug in negative pi over 4. 2 times negative pi over 4 is negative pi over 2. Plus pi over 2 is 0. Sine of 0 is 0. This point is on the graph. Negative pi over 4 plus pi over 4 is 0. Times 2 is 0. Sine of 0 is 0. This point is on the graph. Either way I calculate it, I get the same thing. So it turns out, well, these are exactly the same. I'm going to graph this one function. It has one correct graph. I think this way of writing it is more useful, because when I write it this way, the number that I'm adding or subtracting to x is going to coincide with how much I'm shifting things to the left or to the right. So I'm going to choose to write things this way. If I have it written this way, where there's a number in front of x, and then I'm also adding or subtracting, I'm going to choose to just factor it out. Okay. All right. So, as with the vertical transformations, I'm going to show you two possible ways for evaluating this. Now, one is to just create a table of values to keep track of the transformations. And I think that's a really useful tool, but we're working up to a point where we're going to have one function and we're going to have 4 different transformations. That starts to lead to a rather cumbersome table of values. So it's nice to see which shortcuts we might be comfortable with, if we are. And if we're not, we can always go with the table of values. So if I created a table of values, I would know that Okay, and I'm going to go with this version because we said that was the more user-friendly one because we actually are shifting by pi over 4 to the left. So I know that 2 times x plus pi over 4 is what I'm going to be plugging into sine so that I get out my nice values. But then I need to work backwards to figure out what x is. So I want my input to sine to be my nice quadrantal angle, so 0, pi over 2 pi, 3 pi over 2, and 2 pi. That way, when I plug into sine, I just get 0, 1, 0, negative 1, 0. Okay. But now I need to figure out what my x value is. Okay. So that's going to be solving a bunch of different equations. Right here, this is saying that 2 times x plus pi over 4 is equal to 0. So to solve for x, I'm going to first divide by 2. So x plus pi over 4 is equal to 0. And then I can subtract over the pi over 4. And I get x is negative pi over 4. Nice. Okay. So that's going to be my new starting point, which is consistent with what we just figured out. Okay. Now this is saying that 2 times x plus pi over 4 is equal to pi over 2. To solve for x, I'll divide by 2. That's the same as multiplying by a half. So x plus pi over 4 is equal to pi over 4. Ah, nice. When I subtract pi over 4, I get x is equal to 0. Next one says that 2 times x plus pi over 4 has to equal pi. I'm going to divide both sides by 2. And so we get x plus pi over 4 equals pi over 2. If I multiply that by 2 halves, that's the same as x plus pi over 4 equaling 2 pi over 2. Sorry, 2 pi over 4. And so x would be 2 pi over 4 minus pi over 4, which is pi over 4. Now at this point, I'm going to point out a shortcut. These were evenly spaced. These were quadrantal angles, so we were just counting by pi over 2. Notice these are evenly spaced. Add pi over 4, add pi over 4. I'm just counting by pi over 4. So if I notice that, that can save me a little bit of time, because solving all of these equations was starting to get a little bit tedious. I could do it, I could solve the next two, but I can just say, oh, pi over 4 plus pi over 4 would be 2 pi over 4, which I know will reduce to pi over 2. And then plus pi over 4 again will be 3 pi over 4. Excellent. So that's going to give me the points to plot. All right, so I'm going to mark off. Now I'm not going to bother even to mark off my quadrantal angles. I'm just going to mark off, here's negative pi over 4, 0, pi over 4, 2 pi over 4, which we said was pi over 2, and then 3 pi over 4. My high value is 1, my low value is negative 1, and this is just a sine graph, so it starts at a middle value, high, middle, low, middle. Connect the dots with a nice, smooth, rounded curve. Don't forget your arrows. And there's our graph. All right, excellent. Now, I'm going to just show you another alternative to avoid the table of values. And part of it was actually included in here, just noticing that we were counting over by the same amount. Okay, so here's the basic idea. I know that sine does its thing. I haven't modified it at all. It does its thing as we go from 0 to 2 pi. So this function is going to do its thing as this input, 2x plus pi over 2, varies from 0 to 2 pi. When this thing was equal to 0, that gave us our initial point on that table. When this thing is equal to 2 pi, that gave us our ending point. solving this inequality, I'm essentially solving for two of the x values that I had on that table of values. So I'm going to subtract, whoops. I'm going to change this though. I said I liked going with this version, so it doesn't matter which one I do, but I should be consistent. I said I liked that version better, and I do, so I'm going to write it as 2 times x plus pi over 4. I will get the same results either way. I'll just have to do the arithmetic in a slightly different order. Okay, so here, if I'm solving for x, I'm going to divide each piece of that inequality by 2. Now, 0 divided by anything is still 0. Less than or equal to x plus pi over 4, less than or equal to pi. Now I'm going to subtract pi over 4. So I get negative pi over 4, less than or equal to x, less than or equal to. Notice that pi was the same as 4 pi over 4. 4 pi over 4 minus pi over 4 is 3 pi over 4. Nice. There's my starting point, and there's my ending point. So I just got that information by solving that inequality. Now, what I can do is I can calculate the period. And I actually have two ways of doing that. And that's kind of nice because that's a built-in check that I can do to make sure I haven't made a mistake. The period is supposed to be the length of the interval it takes for sine to do its thing. So that would be the ending point minus the starting point. 3 pi over 4 minus a negative pi over 4, that's 4 pi over 4, or just pi. So it looks like the new period is pi. I can double check that because it's always the case that the period is 2 pi, the original period, dividing by whatever number I was multiplying by, assuming that that's a positive number. And just as a reminder, if it was negative, I'd actually use the fact that sine is odd to just pull the negative in front. Okay. But this would be 2 pi over 2, which is pi. That checks. It's a nice simple check. Didn't make a mistake in calculating the period. Okay, so now I've got that. Okay, but based on my calculations, I just have the starting point and the ending point. I don't have those middle values. But if you think about it, every time we've been graphing things, we've been doing one period of sine or cosine, which goes through all 4 quadrants. So that one period we were dividing into 4 equal pieces. So if my period is pi, I can say the new increment is going to be the new period just divided by 4. We're dividing into 4 equal pieces that would correspond to, originally, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now they're the transformation of those. So the new increment is pi over 4. So that tells me that my x values, I know we were starting at negative pi over 4. I'm just going to count by pi over 4 until I hit my ending value of 3 pi over 4. So negative pi over 4 plus pi over 4 is 0. Plus pi over 4 is pi over 4. Plus another pi over 4 is 2 pi over 4. Now I'm going to want to reduce that one. That's going to reduce to being pi over 2. But as I'm counting over, it's simpler to say pi over 4, 2 pi over 4, and then 3 pi over 4 is my ending point. So just by counting by that, which you'll notice is what we ended up doing when we were creating our table of values for those x values, that gives me all of the x values of my important points. So taking the input, setting that in an inequality so that it's between 0 and 2 pi, solving for x gives you your starting point and your ending point. You can get the period one of 2 ways, ending point minus starting point, or the old period of 2 pi divided by whatever number you're multiplying by x. Okay. And then your new increment, you're just taking that period, dividing it up into 4 pieces. Okay. And then you're starting at your starting point and adding that new increment repeatedly until you hit your ending point. Okay. Some of you may find that you prefer a table of values, and that's totally fine. I want you to be comfortable doing this and understand why you're doing what you're doing. So I recommend the shortcut because I think it just makes you a lot faster at doing these graphs, but speed isn't our primary goal here. Understanding this stuff is. So if you're more comfortable with the table of values, that's totally fine. Okay.